Hi again. So in this video, we're going to continue reviewing for the chapter 1 test. And so we have this problem. We want to factor completely. So it's 3x to the 3 halves minus 12x to the 1 half exponent plus 9x to the negative 1 half. So in class, well, in prior videos and in your homework, you had to do things like this. So there are two ways that we can do it. And the first way is, as it says, factoring. So we're going to try to factor stuff. And so just to kind of review how we factor, I know you guys know how to factor, but just humor me. So if I had something like x to the 6 plus x squared, and I said factor, how would you factor this? Right? This will be, you will take out, that's an error. You will take out the x squared. And so you will say x squared times x to the 4th plus 4. Yeah? I guess I don't need parentheses around the x squared. Just x squared. And because the idea is when you multiply it back in, same basis, when you multiply same basis, you add exponents. So 2 plus 4 is 6, and then x squared times 1 will give you the x squared. All right, so going with that idea, so then if I had x to the 11th plus x to the 7th minus 3x to the 5th, what would you factor out? Right, what's common to all of them? The x to the 5th. So that's the highest one I can take out. So what are we left with? X to the 6 plus x squared minus 3. And so that will be what we're left with, right? So the idea is, again, if you multiply back in, same basis. When you multiply same basis, you add exponents. So 5 plus 6 is 11. 5 plus 2 is 7. And then x to the 5th times negative 3 will give you the minus 3x to the 5th. So on both of these, notice that we are factoring the one with the smallest exponent, right? That's the one that we take out. So back to our problem here, I have 3x to the 3 halves minus 12x to the 1 half plus 9x to the negative 1 half. Right? They all have x to a power. So which one do we take out? We're going to take out the one with the smallest power. So which is the smallest? 3 halves, 1 half, or negative 1 half? Negative 1 half is the smallest power, so that's what we're going to take out. So take out an x to the negative 1 half. And what are we left with? I can take out a 3 also, but I'm going to hold off on that one. So I'm going to have 3x to the what exponent? Right, the idea is when I multiply the same basis, we add exponents, just like we did here. When you multiply the same basis, you add exponents. So 5 plus 6 gave you 11 here. So negative 1 half plus what will give me 3 halves? Or essentially what number minus 1 half gives us 3 halves? And that's 4 halves, right? 4 halves minus 1 half gives us 3 halves. So about 4 halves is 2. So we're going to put that in, minus 12x to the, so what exponent here? When I subtract 1 half, I'm going to get 1 half. That will be 2 halves, right? 2 halves minus 1 half gives us 1 half. But we don't really say 2 halves, we just say plus 9. Since we took out the extra negative 1 half. Now notice that they all have a 3, so let's take the 3 out. So 3x to the negative 1 half. I could have taken that up there, but I really wanted to focus on the exponent. So now I have x squared minus 4x plus 3. It is still a quadratic in there, so we want to make sure that we factor completely. So can this be factored? So can I find two numbers that multiply to positive 3 and add up to negative 4? Yeah, negative 1 and negative 3 work, right? Negative 1 times negative 3 is positive 3. Negative 1 minus 3 is negative 4. So this becomes 3x to the negative 1 half, and then I'm going to have x minus 1, x minus 3, and that will be completely factored. Cool. I did tell you there's a second method. So the other method, if that was a little confusing for you, was 3x to the 3 halves minus 12x to the 1 half, and then plus 9x to the negative 1 half. So we can use the property of exponents that say that when you have a negative, right, if you have x to the negative a, you can write it as 1 over x to the a. So we can use that property of exponents and say this is 3x to the 3 halves minus 12x to the 1 half plus 9 over x to the positive 1 half. Notice that the negative exponent only belongs to the x. It's not to the 9. Otherwise, I would have had 9x parentheses to the negative 1 half. But the 9 is not part of that. All right, so now here I have a fraction. So with fractions, we will get a common denominator. So what's the common denominator? X to the 1 half. So that means multiply top and bottom of these by x to the 1 half. And what do we get? We're going to get x to the 3x to the, when you multiply same basis, you add exponents. So 3 half plus 1 half is 4 halves, which is 2, minus 12x to the 1 half plus 1 half is 2 halves, which is 1, so we don't write that, plus 9. And all of these, don't worry, I didn't forget the denominator, they all have an x to the 1 half in the denominator. Right? That's what this is in the denominator. So putting it all together, same denominator, we can add the numerator, so it's 3x squared minus 12x plus 9. And now we can just work on the numerator. Factor out of 3. And notice that is the same work that we already did upstairs. Or up above. So 3, and that factors into x minus 1, x minus 3, all over x to the 1 half. So are they the same answer? Yes, right? Because now if I take that negative exponent and I put it as a denominator of this, I'm going to get the same answer. Or I can write this with a negative exponent up here. So they are the same answer. So those are two ways that you can do it. It depends on what you're most comfortable with. If you prefer to say, well, I don't like negative exponents, write it as a fraction. So then as soon as you write as a fraction, your next thought should be get a common denominator. So put that same denominator on all the other ones and then add them or subtract them. If you do it this way, we got to think about, okay, I got to factor out the x with the smallest power. And then it's really using properties of exponents. The idea is that when you multiply it back in, you're supposed to get what you started with. Okay? The next video that I'm going to do is working with imaginary numbers. So we're going to solve this problem. Sorry, trying to make the letter bigger and it's not working. Anyway, this is the one that we're going to be working on with imaginary numbers. So if you want to see how this problem is solved, watch the next video.